systematic review and meta-analysis, and I said there are some references for learning systematic review and meta-analysis, and all of them are advanced references. But this slide or this slide set can help you to pass your exam. At first, we talked about the difference between primary study and secondary study. After that, we became familiar with the different kind of secondary study, but we focused on review articles or review studies, including narrative review and systematic review. After that, we talked about the difference between narrative reviews and systematic reviews. And finally, we talked about, or we discussed the difference or the steps of systematic review. For example, formulating question. After that, we should search all databases to find published article, and then we should extract some data from these articles, this published article, and finally we should appraise the quality of the study. And finally, sometimes we can have a meta-analysis, a kind of statistical analysis in systematic review and meta-analysis. Also, we talked about PICO. PICO is an approach for formulating research question. P means patient or population. I, intervention or exposure. C refers to the comparison group, and O means outcome. When we want to do a systematic review on a prevalence study or on prevalence, we don't have comparison group, because when we want to conduct a systematic review on descriptive study, we don't have a comparison group, because in descriptive studies like case series, case report, and cross-sectional, because since this kind of studies are descriptive, we don't have comparison group. After that, I gave you some example about formulating question. For example, early treatment with statin compared to placebo, and its effect on decreased cardiovascular mortality in patients with acute MI is a formulated question. Okay. After search, we should select related studies, and it would be better to do these steps by two independent experts or multiple researchers. For example, when we want to select related article or related document, it would be better to this process is done by two independent experts, because this kind of approach can increase the reliability or validity of your process. After that, you should extract some data from studies like authors, publication year, sample size, study design, study duration, definition of and measurement of outcome and etc. And next step is quality assessment. I think yesterday I talked about previous steps, and right now I'm going to talk about study quality assessment. For quality assessment, there are many checklists or many tools. For example, Cochrane has developed many quality assessment checklists like Cochrane, ROB or Risk of Bias 2 and Robbins. It's very important for you to learn this kind of checklist. Cochrane, ROB and Robbins. And I think I'll send you some or other checklists on WhatsApp today. For example, Newcastle, Ottawa is a different checklist and it's so useful. Another checklist is CASP, C-A-S-P. All of them can help us to assess the quality of studies. Cochrane, ROB, Robbins. It's very important for your exam, the name of checklist. And finally, we can have data analysis or data synthesis in or it's called meta-analysis in a systematic review. Is a kind of weighted average, and it depends on the availability and sustainability of data. It means when we deal with some studies that report some numbers like odds ratio, relative risk, and incidence or prevalence, we can have a meta-analysis. It's a kind of a statistical analysis. As you see, the main goal of meta-analysis is to estimate the overall or the combined effect, as I said yesterday. For example, you want to estimate the prevalence of depression in Tehran or in Iran through a systematic review approach. The first, you should search all databases to find a related article. After that, you should select relevant study, and then you should extract some data from this study, like the prevalence of depression among Iranian people. And finally, you can appraise the quality of the study, and additionally, you can have a data analysis. It means you can combine all reported number or reported prevalence of depression in Europe. It's a kind of weighted. Okay. Right now, I'm gonna give you an example about systematic review. It's a systematic review and meta-analysis study. The research question is the effect of metabolic syndrome on cardiovascular disease. Yes? It's a research question. And the aim of the study is here, or the logic or the justification of the study is here on abstract. To answer this research question, if there is an association between metabolic syndrome and cardiovascular risk, the researchers searched some databases like Cochrane, Embase, and Medline. Yes? After that, they included all related or relevant papers and extract relevant or important data like odds ratio and relative risk, as you said. And I'm going to talk about relative risk and odds ratio in next session and next topic. And finally, they reported a pooled odds ratio or a pooled measure of association. It means they combine all results, all results of previous study and reported in a pooled and overall measure of association named odds ratio or relative risk. Yes, and I send you this article on WhatsApp group. Please take a look at this and give me a summary in next week, for example. Okay. Do you have any question about systematic review? It's clear. Inshallah. Okay. Right now, I'm going to start a new topic and very, very important topic, especially for your exam. Measures of association. I think you have many information, inshallah, about incidence and prevalence, yes? What is incidence and what is prevalence?
Incidence is the measure of new cases, and the prevalence is the measure of all the cases that exist at the time of study.
Exactly. And incidence and prevalence is a kind of, or the kind of descriptive indices. Yes, do you agree? Incidence and prevalence aim to describe a situation, describe a disease like depression, cardiovascular disease, cancer, and etc. Do you agree? Yes, because they try to describe a situation. They describe the status of a population. For example, you should estimate the prevalence of cancer, breast cancer in Asia, for example, or in Iran. Yes, you can use prevalence because you want to describe the health status of a specific population. Okay, but as you know, epidemiology has a lot of aim or objectives. For example, epidemiology aims to determine the extent of disease found in the community. It means the burden of disease in the community. For addressing this objective, we have some tools or some indices like prevalence, incidence, mean, and etc. Okay. But another main objective of epidemiology is to identify the etiology of cause of a disease. For example, what are the risk factors of cardiovascular disease? What are the risk factors of cancer? Or is there association between smoking and lung cancer, or is there the association between, for example, obesity and breast cancer, and etc. when we want to estimate n association between two factors, for example, n exposure and n outcome, like smoking and breast cancer, smoking and lung cancer, you need some specific indices, okay, to assess n association. Because incidence and prevalence are good indices, but they are descriptive indices, not analytical indices. So we want to some measures for to assess the association between two factors. So in this session, we want to revisit the concept of absolute risk. After that, we want to introduce and compare relative risk and odds ratio. Relative risk and odds ratio, two important indices for assessing the association between two factors. And we should learn to calculate and interpret a relative risk in a cohort study, to calculate and interpret an odds ratio index in a cohort study and in a case control study, and describe when odds ratio is a good proxy, for example, or good estimate of relative risk. The main objective of this session is here. It's clear. What's the objective?
On absolute risk.
Yes. Absolute risk. No.
No?
No.
Relative risk.
What's the
Relative.
main objective this session?
Measure of association.
Measure of association. We want to become familiar with some indices to assess association between factors. Because incidence and prevalence refers to descriptive statistics or descriptive approach. But right now we need some indices to assess association between two factors. And two important factors or indicators are odds ratio and relative risk. Okay. It's the definition of epidemiology. As you see, this definition has a lot of components, and two main components is distribution and determinants. Yes? And I think yesterday we talked about descriptive study and analytical study. Descriptive study emerged from distribution component, and analytical studies emerge from determinants component. Yes? So, based on this fact, descriptive indices emerge from distribution component, and measures of association emerge from determinants component. Okay? I think Dr. Feinfeld discussed these topics, yes? The different types of fraction. What is the difference between ratio, proportion, rate, and odds?
In the ratio, the numerator is not a subset of denominator.
In ratio,
The numerator is not a subset of denominator.
Okay.
Both of them are
proportion,
they is a subset. Numerator is a subset
Yes.
of denominator.
and rate.
It is the average of the diseases
And odds,
Probability.
probability, no.
No? It's a ratio for probability. Odds.
Is related to probability. What is the formula of odds? What's the odds formula? How we can calculate odds?
Exposed over unexposed. It's a
Okay.
probability.
Okay. Ratio is a fraction in which numerator is not part of the denominator. It's clear? Like, for example, fetal death ratio or sex ratio. For example, sex ratio in your class. What is sex ratio in your class?
1 to 3. 1 to 2.
1 to 2?
Yeah.
It means the ratio of male to female.
2 to 1. 2 to 1.
11.
Okay. Sex ratio is the number of male to female in your class. Yes? Is sex ratio. Is a kind of ratio. It means the numerator is not part of the denominator. Okay? Proportion, a fraction in which numerator is part of the denominator. For example, prevalence is a kind of proportion. For example, we have a population including, for example, 10,000 people, and some of them have diabetes. And what is the prevalence of the diabetes? 1,500 divided by
10,000.
and you can multiply it, for example, in a specific number, for example, as percent and etc. Okay. Another fraction is rate. It doesn't matter. Right now, it doesn't matter. But the finally is odds. Odds mean the probability of winning divided by the probability of losing. Okay? For example, this is our population or our community. It includes 5%, and 2% have a specific disease, for example, cancer. And what is the risk of cancer? 2 divided by all population. And what is odds?
The ones who have the disease and the ones who don't have the disease. Like,
Yes. 2 diseases and
the
3 healthy people. Yes? And odds means the chance of something happening divided by the chance of it not happening. And I give you some example about odds in this slide. You can calculate them after class.
Excuse me? The chance of something happening, isn't it the risk?
Yes, the chance of something happening, the chance of it not happening.
So,
Yes, the probability of the correct form is the probability of happening divided by the probability of not happening. For example,
so do we have to divide the business people over
for example,
normal people over?
excuse me. We have a population with or include 5%. Yes? What is the probability of this is happening?
2.
No. The probability of 2 divided by
5.
5. Yes? Do you agree?
That's the risk.
2
What is the risk of being disease in this population?
2.
The probability of
2 or 3.
2 persons are disease. Okay, 2 divided by 5. What is the risk? 2 divided 5. Yes? And what is risk of not happening disease?
3.
3 divided by 5.
3 by 5. Yes?
Yes.
Yeah.
So 5 cancels each other. It's 2 actually.
Do you agree?
Yeah.
Yes.
Odds, it's 2 divided by 3. It's odds. For example, you have a population, for example, with 100 people, for example, and 20 of them what is odds?
20 divided
20 divided by 80.
20 divided by 8.
Yeah.
Okay,
is
is the final answer, but the process is 20 divided by 10
divided
divided by,
8, yeah, divide.
and you can simplify this. Okay. Odds very important fraction in epidemiology because one of the most important measure of association in epidemiology, all studies, including cohort studies and case control studies, is odds ratio. And it's so important. And on the other hand, one of the most common approach for estimating an association between two factors in statistics or biostatistics is logistic regression. Logistic regression is an advanced statistical approach in biostatistics, and logistic regression models give you odds ratio. Gives you odds ratio. So odds ratio is very important measure of association. Okay, and based on these fractions, we have some descriptive indices, including incidence and prevalence. And as you mentioned, there are some differences between incidence and prevalence, and the most important difference is that in incidence you deal with new cases, and in the prevalence you deal with all cases. It doesn't matter if they are new or old cases. Yes? And what is the absolute risk? Absolute risk, it means incidence. Incidence is a kind of absolute. Why? Because you don't compare two groups or two populations. When we want to estimate the incidence of a specific disease, we don't compare two groups or two populations. It means absolute risk. Yes? It means the magnitude of the risk in a group of people with a certain exposure. For example, you have a cohort study and you can calculate incidence of a specific disease in exposed group and unexposed group. Both of them are absolute risk because you don't compare these incidents. Okay? For example, sometimes you can have some exposure. It's a outbreak or epidemic, for example, or it's kind of disaster. And you have a lot of foods, and all of them can have or can create this outbreak. For example, egg salad, macaroni, and etc. And it means it's a hypothetical scenario, and you are investigating whether an excess risk is associated with each of the food items or not. It means we have a lot of exposure, and at the same time, I don't have any idea about which of them are the specific exposure, or one of them is the cause of disease. For identifying or for specifying the exposure or the risk factor, you should compare these risks. Okay? For example, you have a cohort study including this table is very important tools in epidemiology, and it's called 2x2 table or contingency table. 2x2 table. Yes? And it helps us to distinguish between different studies. For example, when we have a cohort study, the starting point is here. Some exposed, we should select some exposed person and unexposed person. After that, you should follow them. Yes? In case control, what is the process of or the steps of case control? But based on this 2x2 table.
We're looking for case and control.
Yes. The starting point is selecting case and control. Yes? So, in cohort study, you should select exposure group or exposed group and unexposed group, and after that you should follow them. Okay? When we have a cohort study, 2x2 table is very important tools to assess the association. It's a standard table. And what's the meaning of A cell in table?
People who are exposed and have the disease.
Yes. And and cell B?
Who have been exposed but did not get the disease.
C?
And not exposed and developed the disease.
And D?
Not exposed, not developed.
Please calculate the incidence in a smoker and non-smoker based on this table.
Report?
What? It's a cohort study. Please calculate the incidence of disease in exposed group and non-exposed group.
In exposed group.
No. Right. Please write on a paper.
Can I write it here? Can I write it here? Or what's okay?
Yes. So, the question is that when we want to assess an association between two factors, how can we determine whether an excess risk is associated with each of, for example, food items in our example. Yes? The question is that. And when we want to assess an association, we have two approaches to assessing. It's not clear. No. Please listen to this explanation. After that, calculate or answer that question. I was saying that the question is that what is the best approach to assess an association between two factors? Okay? When we want to assess an association between two factors, the best approach is to compare two results or to measure. Yes? And we can adopt two approaches for calculating a measures of association. The first scenario is ratio approach. A ratio approach. It means when we want to compare two measures by ratio approach. For example, you can divide risk in exposed by risk in non-exposed. It's best or one approach. Another that is difference approach. It means you can subtract risk in non-exposed from risk in exposed. So when we want to assess an association between factors, we have two approaches. One of them is ratio approach, another that is difference approach. Okay? In ratio approach, you should divide the risk in exposed group by risk in non-exposed, or odds in exposed divided by odds in non-exposed, or difference approach. It means you should subtract risk in non-exposed from risk in exposed. And right now, I gave you an example here, a cohort study. Please, just only calculate the incidence of disease, for example, diabetes. For lung cancer. Cancer negative. Okay? Please calculate the incidence of lung cancer in a smoker group. After that, cancer in non-smoker group. Please write your answer. After that, I ask you to tell me about your answers.
Okay.
Finished?
Yeah, 50%. Yeah, okay.
Write your answer.
This is, it's very small.
What should I do? What should I do?
The incidence for smokers and for non-smokers with diabetes.
Should use the first one on the screen.
Just leave that. Just write the incidence. Like how many people are getting sick who smoke. Like how many people have diabetes who smoke, and how many people have, lung cancer. Sorry, lung cancer.
It's easy.
Okay, just do that.
Just say earth is a smoker.
Yeah. Just listen. Okay, so just write the amount of smokers who got diabetes And then the next part, now amount of non-smokers who get diabetes. You don't have to think about that, it's incidence. Incidence means the people who develop the disease. So how many people have been developing the disease from smokers? 50 out of 100 in smokers. And then in the non-smokers,
Please answer
25%.
these questions. Odds in exposure and odds in unexposure.
Yeah, it's okay. It's fine. Now he is asking to write the incidence. Incidence means the number of people who develop a disease. So in smokers, 50% develop cancer.
Yes.
Cancer.
Risk in exposed, risk in
Among
unexposed,
smokers,
odds in exposure.
25%. That's incidence basically. The amount of people who develop a disease. No, nothing. For incidence, you don't calculate much. Just amount of people who got sick.
Okay. Asif Amara. Ibrahim Abbas. Osama Qasim. Ashraf Mahmash.
If you want to put in percentage, just
Al-Qazi. Am I right? Al-Qazi Ali Hussein Ali.
and it's 50%.
Qasim Abdul Nabi. The risk in unexposed.
25.
25%.
0.5.
Yes, 25%. What is odds in exposed group?
Which is 1.
Which is 1.
No, 50 by 50. It's better, but 1 is correct.
So does this mean that if you smoke, you will definitely get lung cancer? Like this is what the odds say?
It means the chance of, or the probability of contracting cancer is equal to don't contracting cancer in a smoker person.
Oh, okay. It's not a percentage. It's not a percentage.
Yes. It's not. It doesn't have any unit. Yes.
So
it
you
doesn't
can have an odd. You can have, for example, maybe odd, which is 1.5, which means those who are exposed are more likely to get
Yes.
cancer than those.
Yes. And what is odds in unexposed group?
5 over 7.
25.
Over 7. You asked me this part. You were asking me this before? Cancer.
Oh my god.
Cancer negative. I did not know that you wrote that. I did not know that you could sing us this as well. That's why I mean, I know you didn't ask, but I'm just saying.
All of these indices are descriptive. Yes, because based on each index, you cannot draw a conclusion or you cannot estimate measures of association. But we learn two approaches to assess an association. One of them is ratio approach, and another one is difference. Okay. Right now, we want to talk about ratio approach. Finally, at the end of the class, we will talk about absolute or difference approach. But right now, we want to assess the association between smoking or being a smoker and lung cancer with ratio approach or through or using ratio approach. One of the most common index for assessing an association between an exposure and an outcome is risk ratio or relative risk. Yes? Risk ratio or relative risk. Risk ratio or relative risk means the risk in exposed group divided by
Risk in non-exposed.
risk in unexposed group. or relative risk. Please calculate relative risk for this example. Please calculate. Based on this example, please calculate relative risk.
2.
2. Okay. And another index is odds ratio. Odds in exposed group Okay, please calculate this index.
3. Three.
Three? Yes. It's clear. Okay. As I said, we have two approaches to assess an association between two factors, exposure and outcome. The first approach is ratio, and another is difference. Based on ratio, we have some indices, including risk ratio and odds ratio. Rate ratio is so important factors and indicators, but right now it's out of our scope, and I'm not going to talk about this rate ratio. And I want to focus on risk ratio and odds ratio. Okay. And another approach is difference approach, and based on this approach, we can calculate risk difference and attributable risk. In the following, we can calculate and interpret this index. Okay. Relative risk is based on relative measures or ratio-based measure based on multiply and divided, and another one is difference. ratio measures tell us about the strength of association between exposure and disease, and are of central importance to studying the etiology of disease. When we want to assess the causation or the risk factors of a specific disease, ratio measures is more important than difference approach. Difference approach or difference measure are more appropriate for assessing the public health implication of an exposure. It has many usage in public health policy or public health intervention, risk difference. But ratio measures is more common, and it tells us many information about strength of association. In Persian, قدرت رابطه. Yes? You are absent.
No.
Sit. Okay. This table is, as I said, is very important in epidemiology because it's a fundamental or essential tools in epidemiology for analyzing associations between two factors, for example, exposure and outcome. And for making it easier, we imagine that we have a dichotomous or binary outcome. What does it mean, binary? Two
outcomes.
No. It means our outcome has two types, having or not having. For example, our exposure has two types, being exposed and non-exposed. Okay? Because for making the process easier, imagine that we want to assess an association between a binary exposure and a binary outcome. Based on this imagination, we have a 2x2 table, and A, B, C, D, and you correctly interpret this table. A means number of exposed individuals who develop the outcome. B, number of exposed individuals who didn't not develop the outcome. Cell C, number of non-exposed individuals who develop the outcome. And D, what does it mean, D? Okay. For calculating relative risk in a cohort study, this is its formula. Incidence in exposed divided by incidence in unexposed. It means A divided by A plus B and C divided by C plus D. And for calculation of odds ratio in a cohort study, you should calculate odds in exposed group and odds in unexposed group. Odds in exposed group in a standard 2x2 table means A divided by B, and odds in unexposed group C divided by B. Okay? In a standard 2x2 table. Okay. And odds ratio means finally A multiplied D divided by B multiplied C. Okay?
Okay.
It's a simple form of this calculation. And what's the meaning of different number of relative risks? If relative risk is greater than 1, it means risk in exposed group is greater than risk in unexposed group. And it means there is a positive association, or it means your factor or your factor or your exposure is a risk factor. But when relative risk is less than 1, it means risk in exposed is less than risk in unexposed. And it means your exposure is protective. Can you give me an example about protective effects or protective exposure?
Wearing a mask.
Please give me an example about a protective factor, not risk factor. Vaccine. Vaccine is a protective factor. For example, you have two groups, one of them receive vaccine and one group not receive a vaccine. After that, you calculate incidence of, for example, mortality or get disease in vaccine group and non-vaccine. And it's logical to see a relative risk less than 1 because vaccine is a protective factor. Yes? And when relative risk is equal to 1, it means no association. And odds ratio has the same meaning. When odds ratio is greater than 1, it means there is a positive association or risk factor. When odds ratio is less than 1, it means you have a protective factor or protective exposure. And when OR is equal 1, it means no association. Please solve this problem. Answer this question. A researcher is studying 300 individuals exposed to a potential carcinogen and 500 people who were not exposed to this potential carcinogen. After 5 years follow-up, a number of exposed people are diagnosed with the lung cancer, and one of the unexposed individuals are also diagnosed with the disease. Please calculate the relative risk and odds ratio of contracting the disease. Please write the answer. You can leave the class because you are sick and it's possible to give this is to another person. Please. Your absence is justified.
Risk of incidents might be
Okay.
Please calculate these indices, and after that, please interpret them. It means, what does it mean, the value of relative risk and odds ratio in this example? So so far, we learned two indicators or two indices to assess an association in cohort study, relative risk and odds ratio. Okay? Please calculate them. Relative risk and odds ratio. Please design or depict 2x2 table for this question. At first, it's so helpful for your learning. Please depict 2x2 table for this example, please. Please, at first, depict 2x2 table. Finish? Please depict 2x2 table at first.
Lung cancer. Well, you should write your cancer issues. The first thing you have lung cancer. In the first year, after 5 years. The second one.
The people who don't have exposure to
In
carcinogen.
which squared? Squared.
The low.
Please calculate odds ratio.
4.0.
No, please calculate after that I ask you.
Done. We're done.
Odds ratio. Odds ratios. Odds ratio.
Please calculate odds ratio. Okay, finish. What's the answer?
4.5.
The best approach for calculating odds ratio is here. In the standard 2x2 table, this cell is A. Yes? It's B, it's C,
It's
and
D.
it is D. Yes? For calculating odds ratio, the best scenario is after determining these cells, AB divided by What's the answer?
Oh,
4.
4.4.
What's the interpretation of odds ratio? The odds of. This is the odds of lung cancer in exposure group or exposed group is 4 times of the odds in unexposed group. And it means your exposure or carcinogen is a risk factor for lung cancer. Why? Because it's greater than or more than 1. Okay. Before our break, please calculate odds ratio, only odds ratio for this example. Odds ratio is, for example, this is
1.
1.
1. What does it mean? It means there is no association between exposure and outcome. Why? Because odds ratio is 1. And odds ratio and relative risk range from 0 to
1.
okay. Okay.
Rest.
I think the answer of this question is here. And the interpretation of relative risk, the risk of disease in the exposed group is 2.58 times as high as the risk of disease in the unexposed group.
See.
And relative
2.4.
excuse me,
Ah.
odds ratio,
Yeah.
the odds of lung cancer occurring in exposed group are 4.08 times the odds of lung cancer occurring in the unexposed. Please calculate relative risk and odds ratio for this example. After that, we will have a break for 15 or 20 minutes.
Okay, straight on. Just reading.
Please calculate. Please be serious about your exam, your final exam. The rate of fail is very high in epidemiology subject, unfortunately.
Why?
Why?
What
Because
do
you are very clever.
What do you want us to calculate?
Oh.
What should we calculate?
Why?
What should we calculate?
Odds ratio and relative risk. Both of them. Please. The rate of failing is high because unfortunately you don't spend enough time for practicing in epidemiology, for learning epidemiology. Yesterday I sent you Gordy's book. Please check the material and the content of this book. It's very important help.
Calculate.
As I said, it has many questions at the end of the chapter. Please solve them.
I don't have
Check
charge.
it if you want.
It's just fine. News money. Multiple toxin. Support لها 30,000.
What is relative risk? 6. And what is odds ratio?
6.
the aim of solving this or answering this example is that when the event, or when the outcome, your outcome, is rare. What does it mean, rare?
It doesn't happen often.
Yes. It's in, I think in Persian, nadir, kamyab. I think in Arabic, yes?
Yes.
Qalil. Yes? When your event or your outcome is rare in the population, the odds ratio approximates the relative risk. It means the odds and probability of event are very similar. In previous example, relative risk was 2, I think, and odds ratio was 4. And the difference between relative risk and odds ratio was very high. But in this scenario, since your outcome is rare, the difference between relative risk and odds ratio is very or ignorable. Yes, it's very little. So in this situation, when you have a rare outcome, relative risk and odds ratio is very close, and it's so important in epidemiology. And another important point is that in cohort studies, we have 3 approaches to assess an association, or we have 3 indices based on ratio approach to calculate association or to measure the association between exposure and outcome. Risk ratio, rate ratio, and odds ratio. As I said, rate ratio is out of scope, but there are 3 ratio-based approach to assess an association. Risk ratio, odds ratio, and rate ratio. And what is the best index for assessing an association in cohort study among these? Risk ratio. Risk ratio is better than odds ratio and rate ratio. But odds ratio is very important because, as I said, odds ratio can estimate using logistic regression model or using a statistical analysis. So both of them are correct and both of them are important, but relative risk is better. Yes? Okay. We can have a break to